Hello, everyone. This week, we will talk about energy efficiency, behavior, and sustainable consumption. We will focus on energy efficiency, but in order to explain efficiency, it will have a lot to do with behavior change and correspondingly the sustainable consumption and production. Some analytical questions for this lecture, such as we all know energy efficiency is a very good thing, but why is not everybody doing it? So we asked this question in the previous lecture, and in this lecture, we will try to discuss and explore an explanation for it. And how to design incentive programs to change people's behavior. We know human behavior is very complicated, but is there any possibility for us to acknowledge human behavior and so we can design policies to address it? We will discuss the idea of a lodge that to provide some incentives, so make it easier for people to make decisions and take actions. One common concept in the energy efficiency field is the idea of a rebound. As efficiency improve, and people may use more because it's getting cheaper and other factors. But what is rebound? How big is rebound? And what to do with rebound? We will discuss rebound in great detail, and we also cover sustainable energy consumption, but what policies to push for sustainable energy consumption. First, energy efficiency is a very important topic, and energy efficiency is basically as the technology improve, the energy we consume to produce one unit of service that is coming down. So that improve the energy efficiency. No matter you measure it by energy service per kilowatt hour or other measures, energy efficiency help save cost and improve energy service, and it has all kinds of benefits. And because it saves cost, many people saying that energy efficiency is not just low-hanging fruit, that it's very easy to do, but also a fruit on the ground that you can just pick up. Others may say energy efficiency, you save, you avoid building new power plants and other investments to produce that one extra of energy consumption otherwise. We need to differentiate a little bit between energy efficiency and energy conservation or energy saving. One focus on you save energy. Let's say if you leave your house, you turn off your lights, then that's energy conservation. You reduce energy consumption otherwise, right? Energy efficiency, though, it's you need the energy service, but you do it in a more efficient way. For example, you change all your light bulbs to LED, which is maybe 10 times more efficient. So that's energy efficiency. Use more energy efficient appliances, lighting, and to use more efficient technologies for the same energy service you may enjoy. For example, you change lights to LED, to change your heating, cooling to heat pumps, which may use just 1/3 of the energy to provide the same thermal comfort. And energy efficiency can contribute to economic efficiency. Very often, people use energy intensity to measure economic efficiency, that the energy consumption per unit of GDP. As you can see here, from 1960s to 2018, data from our world data shows major economies, the economic efficiency or energy intensity is improving, and world average also improved. China might be an outlier majorly because manufacturing and the energy intensity of some heavy industry even is improving, but comparing to other countries may not seem that obvious, but there is a reason for that. So this shows energy efficiency is very important, not just for economic efficiency, but not just for improve the maybe save costs, improve the service and other benefits. Correspondingly, all those savings need to less energy consumption, less pollutions from energy production, and that create water saving, pollution reduction, carbon emission mitigation, and other co-benefits we discussed in the previous lectures. Recall the demand and abatement cost curve. We discussed the cost curve in the climate policy ideas. Excuse me. So we have the cost of marginal cost of CO2 abatement, 1 ton of CO2 abatement on the vertical axis. On the horizontal axis is cumulative carbon mitigation rank ordered by the cost of abatement and the mitigation potential for each technology. Why I'm showing this chart again is because I mentioned there are technologies whose costs are elective, which means that they save cost. And as you can see here, most of them are energy efficiency measures. Change L to LED, improve residential commercial building, energy efficiency measures. So that means energy efficiency is again a net gain if we do it. So then the question is, if energy efficiency is such a good thing, why people, or why is not everybody's doing it? So that's the question, and that brings the discussion of a so-called energy efficiency gap. The energy efficiency gap described a phenomena that it's a gap between what's theoretically possible and what has been done in reality, right? we know energy efficiency is good, and we know it has this much benefits, and yet in reality it only achieved a small portion of that possibility. And the difference between possibility and the reality is the energy efficiency gap. So there are multiple reasons. This summary chart or table from a paper that I posted, and it's also shown on in the source, that there are market failure and behavioral failure that caused the gap. Market failure such as environmental externalities, energy security externalities. So the benefits of energy efficiency are not priced, such as emission price, energy security. When you need more energy, you create it's an impact to energy security, right? Especially rely on import and other or strategic reserves. Capital market failure, especially if because energy efficiency programs, you might need some upfront investment. For example, if you want to replace your AC units with heat pump, you might need known financial services, and very often those programs might not provide for energy efficiency projects. There are also innovative or innovation market failures, such as R&D or learning by doing. There are less incentives for only market adoption. There are also some information problems. Maybe you just don't know it, why you're not doing it. For example, LED might be good, but many people might not aware there is an option for LED or option for heat pump, and they might think heat pump is not reliable for extreme cold weather. Or those informations are very important for consumers to make the right decision. And information is not free. Even it's available, it takes efforts to know it, and take efforts to judge from what's reliable and what's maybe just misinformation. There are also some behavior failures. There are, for example, bounded rationality, or there are different theories behind it. People make decisions within their boundary, limited information, limited efforts, limited time, and not always rational, not always based on protecting the environment, or not always based on the lowest cost, sometimes impact by other people's behavior, sometimes impact by no matter what information you receive, or friends' recommendation, etc. There are also some mixed reasons. A typical example is the principal agent problem, that let's say you live in a rented house. Yes, more energy efficiency products might save energy or reduce the cost, but you simply do not have the incentive to invest the upfront cost if you just rent the apartment for a year, for example. It also depends who will pay the bill if it's paid by the landlord, the rental, do not even have any incentive to do energy efficiency. If the rent to pay the bill, then might be, it also depends how long you will stay there. There are many interesting discussions on that. This is called the principal agent problem. So briefly, this captured some of the discussion of what caused the energy efficiency gap and what policies may help address the gap, including what we will discuss information. So authoritative sources can provide information such as the Energy Star, and for energy efficient products, it will have a Energy Star label, and it will show you for average use what cost it will save each year, and how much energy it will reduce each year. And that will have, you don't have to figure out by yourself, and you immediately get the most important information needed for your decision. And that also makes products with the label more readable and competitive. So that's one way to reduce the information cost for individual consumers. Or standards. If information is so complicated, you don't have to figure out all the details of a fridge or a dishwasher or washing machine, right? So one way to do it is for any product in the market, you have to achieve a minimum energy efficiency standards. Otherwise, you are not allowed to go to the market. So that's a response to information failure, that it could be a very good policy if information is too costly or ineffective, or it takes too much efforts to figure out the details. Think about how you buy computers, how you buy there are so many options, and or if you buy a car, and some you just don't have the time to compare all the details. However, it might eliminate consumer producer choices. Some people might willing to pay high price or even a tax to use certain products. For example, SUV, which might not be energy efficient but provide extra other services. So in theory, if they are willing to pay high prices for the doctor or high gasoline prices, the society, if the economy works, can beneficial, which means that they are extra paying compensate for those energy efficiency measures, and if the price is right. It also eliminates cost of acquiring and understanding information. That's a good thing. And so those minimum standards can also push the market to produce high quality products. From the economic theory, this create more efficient products. At the same time, it might create or eliminate customer choices that create a so-called deadweight loss. The standards can also be a response to the externalities that we know some products, if they are too or too inefficient or creating too much pollution, then they have to out of market, and that's a response to externalities, right? Standards can also be challenging because the market innovation can happen very quickly, and if the standards is lagging behind the market, then sometimes the standards can limit the innovation, because for producers, as long as you know you've meet the standards, you are allowed in the market, and you have less incentive to invest in R&D to produce better products. So one way to do it is to regularly update the standards. For example, there are groups doing research to update the standard every 2 years, and so it can update and catch up the latest advancement in technology innovation. So there are a lot of opportunities there, and what's the right mechanisms to improve the standards and at the same time not hurt the manufacturers. Energy efficiency and other behavior change really has a big role to play in the IEA's net zero emission systems by 2050. And you can see here energy efficiency and behavior change really contribute about 12% of the reduction of change in final energy consumption. That means the impact of energy efficiency and behavior changes can really reduce our energy consumption, and that for any 1 unit of energy reduced, we avoid building new plants or new projects to produce that extra unit of energy. There are different sources of how those behavior change can contribute and what are the policy options. For example, in low-car cities, there are changes like phasing out internal combustion vehicles and introduce EVs, and try to encourage more rideshare or using more public transportation, fuel efficient driving, improve the fuel efficiency of the car, and to improve the driving behavior, the so-called eco-driving, and reduce the use of air conditioning while driving, and stop the engine if the waiting time is too long. Many of the energy consumption might relate to what car we drive and how do we drive it. Reduce regional flights and using more mass transit those include high-speed rail, subway, metro, intercity railways, and to create price mechanisms to encourage the usage of this public transit and reduce international flights using more online conferencing, and those measures can help. Space heating, space cooling, also a major source. We can adjust the temperature using higher temperature when cooling, using lower temperature when heating, right? And other services like using higher energy efficiency standards or building code, so it can have better seal or weathering, and all this can really contribute, and it will help fuel those to achieve their reduction as visioned in the net zero emission energy systems. However, to change human behavior is really not easy, and that's embedded in the complexity of human behavior. There are explanations on that. One series, our brain has two systems. One system is fast, one system is slow. One system, the fast system can be unconscious, and the slow system conscious. The fast system make automatic decisions. Like when you're driving, you don't think very hard about how you drive. Your brain automatically make those decisions unconsciously very often. But when you're doing your homework, for example, you need to pay attention, you really read carefully, you make decisions slow, and you make efforts, and you do try to make everything correct, right? So I appreciate that, and that's the so-called slow system, and it's very often after carefully check your results are very reliable. And this is constant contrast to your everyday decisions. Let's say how many decisions you have to make every day, right? What time to get up, what do you wear, what do you eat for breakfast, how do you get to work? There are many decisions that you just simply create a habit, right? You do it every day, and you kind of rely on some of the habits that you make, and so you can focus more on the system that rely on your efforts. So with better understanding of how the two systems work, we can have better understanding of how we make decisions, and how can we use these two systems to help people make decisions. For energy efficiency, we hope that at the beginning it may be a slow system, but we hope to convert that to a fast system that people make the decisions without too much effort, and still good for the environment, good for the climate, and good for the consumer. That involves some good program design, and that's what we will discuss. Another complexity is the so-called Maslow's hierarchy of the human needs. From basic needs that covers physiological needs or safety needs to more psychological needs, the esteem needs, belonging needs, and love. And at the top is self-fulfillment or self-actualization. It might have a hierarchy, but we have all the needs here, and we may have priorities. Some needs are more fundamental, but those are all human needs, and we act to those incentives to satisfy those human needs. And it's very important that we understand them and try to create the right incentives that will help motivate human behavior. And that's the art of how to create incentive for behavior change. And there's also theory of a stage of a change, from early stage, the pre-contemplation to contemplate, and to the stage of a determination. And once you decide it, you take actions, relapse, maintenance, the theory or the cycle of a decision cycle. And in each stage, you need some information, incentives, and reasons for action, and their opportunity for intervention. And for policy, really to create the incentive or the right incentive that can lead the decision point to the action needed to make our world a better place, to take the climate actions needed to save the planet, right? So there are a whole lot of discussions on what policies. One very interesting is the idea of a lodge, that we kind of make decisions based on all sorts of incentive or information, ideas, efforts. But there's something that can really push us to the point that we take that action. So this is not just in energy efficiency, it's in many other fields, and it has broad implications of how public policy can help people make better decisions. For sure, we react to incentives, and we need understand the mapping from decisions to impacts, and there are defaults. A very important example or famous example is because there are too many options, and we kind of are losing from those options, and it's hard to make it harder to make decisions. Options not always good, and if it has default, then people or human may just accept the default option. One famous example is if you change, if the DMV form has an option that if you are willing to donate organ, so they change from a default option from winning, from not winning to winning, immediately raise the percentage of people who is willing to donate organ. So the default. One other example is we know save for retirement is good, and but people tend to use that money to consume at today, not saving for retirement. So there are mandates or default that you company, and the default, if you do not change, you will save 3% of your salary for retirement. Examples like that. If feedback, people react to feedback, and the feedback also create incentive and the right information for follow-up actions. Expect error. We might make mistakes, and that will or the feedback or the consequences will lead to corrections of our decisions. If the options or the choices is too complicated, we need a better structure it, and what the decision point and what are the consequences of the decision, what are the different paths, and so we have better option or better decision support to know what are the outcome and the costs to achieve that outcome. Those structured I mentioned exactly in the pathways study, and it's an example of how structured choices can help us make better decisions. Large as a popular book, and it's also create the discussion that people might make decisions. So we need that knowledge to keep human to the desired outcome of the society. If you're interested, definitely encourage you to know more about what different bodies discussed in the book and beyond, not just in the energy and climate field. It's a fascinating discussion of what can we do to help people make wise decisions. Another very interesting concept in the discussion of energy efficiency is the rebound. Rebound is an effect that as energy efficiency improves, people use more of energy. So different reasons when energy efficiency improve, the cost usually coming down, and when costs coming down, people use more, and that need to increase of energy use. So there are direct rebound, indirect rebound, and economy-wide rebound. Direct rebound is people use more of more efficient services. I mentioned consumer drives more with a more fuel efficient car because the cost. And indirect rebound, let's say you spend less money on gasoline if you have a more efficient car, but you consuming the money you save, you consume more other product, and that consumes energy, right? When you save from what you drive, but you buy a ticket to have a holiday, for example. That is indirect rebound. Economic rebound is more efficient production and shifting in demand, total economic structure and growth. For example, more efficient steam engine, increased production changes, and that lead to economic growth. So any saving in the energy efficiency that create more economic activity, and that lead to economic wide rebound. The economic grow, the economic consumes more energy. So it's very interesting to ask the question. We already explained what is rebound, and natural question is how big is a rebound, right? And I'll explain a little bit more of the economics of rebound. Energy efficiency lower the cost of usage, so it increased usage, and energy efficiency may also lower energy cost, and that further increase the rebound effect. But sometimes energy efficiency also raise the upfront cost of appliances, and that reduce total sales. With energy efficient products very often cost more in the market to buy. That's why energy efficiency might be hot if it involves higher upfront cost, and people may not have the investment ready for that extra payment. So those questions lead to the discussion of how big is rebound. There are estimations, and one of the interesting discussion on the fuel economy standards by 2025, and estimation of how this might create energy saving. And as you can see here, compared to a no policy and policy plus behavior change, less fuel is used due to the great efficiency, that about 7% of reduction, and the rebound is about 2%. Behavior change push consumption back up, and still overall a 5% reduction that created by the fuel economy standard. And that's good, right? It may not as big as the policy was designed, but still it create energy savings. In addition, rebound can be good. Let's say you save on energy efficiency products, and you use that saving for a holiday vacation. That create a rebound, but you feel happier, right? That increase your social welfare, and it's also good for the society too, because that creates the holiday economy. It creates jobs for those people who run the tourism business. So rebound loss is not necessarily a failure. If your goal is energy saving, then rebound, yes, it creates some problems there. But if your goal is improve social welfare, then rebound can be a good thing. So when design policy, do not worry too much about rebound. For sure, we will study it and see how big is rebound and how we will consider it when we try to figure out the energy saving potential. It might not as big as the policy is designed, but it's very important to know rebound is not the goal. We better focus more on social welfare. Lastly, we will spend a few minutes on sustainable energy consumption, because it's very important, and it's part of the action we need to take in order to reduce the impact to the planet. Sustainable production and consumption will help address, just think about the life cycle of any products. It can start from harvesting, transport, to storage, to processing, and to household, to grocery store, to restaurant. The production, the logistics, and the whole life chain of any products, they all involve energy consumption. Some involve water consumption and related carbon emission and pollution. So if we can reduce the total food wasted, or reduce the total food loss over the process, we reduce the impact to the ecosystem. And in the food industry, too much food is being lost or wasted during the processing and the process of this non life chain, and that's a waste of energy, and of course emissions too. So reduce food waste. Only buy the food that you need. For example, in the United States, many of the food is wasted in the fridge because people buy more than they need. And just think about the food through the whole value chain and to your mouth, and before it goes in the mouth to feed you, and it's going bad and you throw it away, and even the garbage collection will consume energy. So that's what we are talking about, the sustainable energy consumption, or sustainable consumption that reduce our energy and the carbon footprint. So absolute reduction in material and energy we consume, material including food and water and other services. And that means we need to change our whole economy and how our economy and society operate. We need change our idea to measure wealth from how much we consume, to really measure the progress and the well-being of a human being, and to really develop the technological innovation and efficiency game that help us to refine production processes, to reduce losses during the production and logistic processes. For example, the use of a fridge in transporting is a very important invention to reduce the loss of vegetables, the loss of meat and food. We also need to recognize that consumption will need, even we want to reduce the loss, but for populations that still live in poverty, their consumption of material, food, and the goods will still going up. So that's the equity issue that we were discussing in next lecture. And we also need a transformation of our economy from continuous growth to growth within the limits of the finite planet. Those limits including ecosystem and other material limits to reduce the impact to the ecosystem. And this discussion on the growth, degrowth, and limit to growth and sustainable growth is what embedded in the discussion. So for a household who need really there are many measures that it can help, and if everybody is doing their part, multiplied by the population, now we are approaching the 8 billion population, and that can create a big impact or change on our impact to the planet. So to summarize what we have discussed in this lecture, we discussed energy efficiency and its role in achieving net zero emission energy systems. And we know energy efficiency is a good thing, but there are barriers for energy efficiency, and that's the energy efficiency gap we need to address. And information programs, policies such as standards can help address the energy efficiency gap. Human behavior is complicated, but we are making progress to understand it better, and those understanding will help us to design better policy to motivate people and to help people to make decisions that is good both for themselves and also for the climate. Rebound is real, but as we discussed, it might be overplayed, and rebound could be good if improves social welfare. So the goal for the energy efficiency programs is not to reduce rebound, even though it's it could we will try to reduce the rebound, but it should be focused more on social welfare and do not let the rebound block the way for the improvement of energy efficiency. Lastly, sustainable consumption and production is very important. It reduces our impact to the material and our demand for the material, and reduce our impact to the ecosystem. And we need to think about how to make it within the Earth's limits and still improve human economy. So that's all for today's lecture. And please read any recommended or linked papers links that I shared in this lecture, and definitely encourage you to know more of those topics. This is a fascinating area of growing research, and it's also related to, very interesting to our daily life. Thank you.